No, please mute yourself. It is creating noise if there is no question. So, good evening, everyone. Today we will discuss about the fundamentals and the process description of physical and thermal conversion processes. Especially, we are focusing on the biomass in this session. Can you please mute yourself, Madan Prakash?
Yes, sir. Yes, madam.
Yeah, yeah. Thank you. So, starting with the physical processes, we have already discussed in the past classes that size reduction as well as drying, these are some basic necessary physical processes. So, in today's class, we will discuss in details like what are the characteristics and fundamentals and what are the equipments we use in the process of physical treatment, pre-treatment of the biomass. So we know that biomass, which is made up of different kind of minerals, moistures, and organic molecules. So there are, we know, the several compositional variances um, in the different biomass compositions. So the moisture content of the terrestrial species, which is relatively low compared to the aquatics biomass, or you can consider the municipal biosolids and animal manures. So these aquatic municipal wastes and the animal manures, they have the higher moisture content compared to the terrestrial biomasses. And the woody biomass species have low ash concentrations, but certain aquatic organisms and also the agricultural crops, they have very high ash content. So we are discussing about the moisture content and the high ash content, or the ash content of different biomass species, because this will affect our conversion processes as well as treatment, pre-treatment processes. So how this will impact that when there is high content of the free moisture and ash, the heating value of the bulk biomass remains same, but when it is in the dry conditions, this biomass material can exhibit notable variation. That means when we decrease the moisture content and we manage to decrease the ash content of the biomass, then their heating value of that biomass sources as a fuel, that will increase. So, when we consider the untreated municipal biosolids, they are often inappropriate for the direct application in the thermochemical conversion because they contain a significant quantity of the moisture. Under usual circumstances, thus feedstock cannot support self-sustaining combustion process unless we do the drying or dewatering treatment to reduce the moisture content at a great extent. Now, the physical conversion techniques, which are very essential for converting the raw biomass into energy rich product in the field of the biomass utilization and conversion. Two crucial processes that are frequently used to lower the moisture content of the biomass sources, different biomass sources, those are first one is dewatering and then followed by drying. These two treatment improve the thermal efficiency and also it improves the storage stability of the biomass sources. Thus, the enhancement of the heat transmission within the biomass sources is achieved by size reduction, followed by energy densification of the biomass, such as pellet formation or briquette formation, through compacting or densification process. Biomass processes heavily relies on the separation techniques. There are different separation techniques that they may take possible to isolate certain components for later use and extract important ingredients and remove the contaminants from our biomass sources. So in this slide we have discussed about the importance of removal of moisture and the physical conversion physical processes. It involves um, dewatering, sorry, it involves I'm writing here maybe at the end. It involves dewatering, drying, densification, size reduction, then followed by densification and then separation. So these are the physical processes we are going to discuss in the subsequent slides. First one, we are going to discuss dewatering and drying. Dewatering is the process of removing completely or some of the water content from the biomass. Now we know that water content of the biomass, there are two types of water content. One is inherent water content and another one is surface water content or the exterior water content. So the inherent water content, those are inherently in nature, it is present within the biomass and it is not even affected by the environment. But the surface water content, which are easily highly affected by the water by the environment. So these are typically two kind of water content we are talking about. So dewatering, it is the process of removing the water content which is mostly taken out as a vapor form. Okay, so it can be essential part to dry the raw feed material before conversion in certain situations where an unwanted material or virgin biomass is thermally treated directly for energy retrieval. Otherwise, the conversion process may use more energy than it that may ultimately be used to create in the form of energy or fuel. The high moisture content of the biomass in its natural condition, it reduces the energy content and makes it difficult to manage or even to store, because if the biomass source is having lot of moisture content, it will, if we store in that condition, having high moisture biomass source, then it may automatically start degrading by the presence of different organisms, right? So our storage will be damaged, the source will be damaged. So and other, if the moisture content is very high, then it will not thermochemically suitable for those processes, because it will for removing that moisture itself in the process of thermochemical conversion, it will take lot of energy. So we are losing the energy in the form of moisture removing. So it is not well practiced to directly use the virgin biomass into the thermochemical conversion processes or any other conversion processes. So we are uh, suggesting it for the dewatering and drying treatment as a pre-treatment process of the biomass. So we know that among the categories of the feedstock of higher water content, aquatic biomass, they can be categorized because they have lot of moisture content. Inherent and extra and surface moisture content is very high. Freshly collected green terrestrial biomass typically has moisture content of 40 to 60 weight%. Now the municipal solid waste that we are talking about, it is often uh, received as a moisture content of 10 to 30 weight% water content based on the period of year and place from where it is collected. So the decrease in the moisture content will encourage the effective gasification process as well as combustion and other conversion of the biomass into variety of bioenergy product. Industrial dryers include spray dryer, drum dryer, convection ovens can draw raw material more quickly if they are not suitable enough for to be dried by direct solar means. The use of some hot stack gases in the forced air furnaces and drying system can occasionally be used to equally effective large scale biomass drying application. Using the mechanical forces to extract water from the biomass is also known as mechanical dewatering. Commonly used methods include centrifugation, filtering, and pressing. So these are the method for mechanically removing the water from the biomass sources. By rotating the biomass quickly, centrifugation uses centrifugal force to separate the water from the biomass. Now to separate the liquid components, the biomass is then filtered via porous media using mechanical pressure to remove the water from the biomass. The process of the thermal dewatering that we discussed about the mechanical dewatering. Now in the process of the thermal dewatering, it uses heat to help remove water from the biomass. Techniques that include thermal pressing, steam explosion, and evaporation, these are often employed as thermal dewatering process for the biomass sources. Water is heated and it turns into vapor via evaporation, which allows the biomass to be extracted from it. Now, the high pressure steam is used in the steam explosion method to break up the biomass structure as well as it removes the water very easily. By submitting the biomass to high pressure temperature condition, thermal pressing encourages the release of water. Mechanical dewatering with assistant of thermal dewatering is a relatively new method. That is the, you can say this is the combined method of mechanical dewatering and thermal dewatering for the separation of liquids or solids in an environment friendly manner. The main concept of this combined technology is to provide high temperature in the mechanical dewatering process to improve the removal of the moisture content. Drying, the next after dewatering, we are going for the process of drying. It is one of the effective pre-treatment process to be considered for the biomass. By reducing the boiler's auxiliary capacity, drying biomass improves the boiler efficiency and reduces the emission from the boiler. as well as it increases its heating capacity and combustion properties. Now, the fuel pre-drying or the biomass pre-drying could significantly reduce the energy loss in the combustion process. Moreover, the pre-drying of biomass it results in the reduction of the required fuel flow rate for achieving the desired boiler output. Thereby, it influence the fuel transformation transportation as well as reduce the storage capacity. Now we already discussed that how the moisture content is very crucial for our transportation and storage capacity of the biomass. It also crucial for combustion or incineration gasification processes. Those are categorized for the uh, thermochemical process. Also pelletization, it comes under densification or compaction process. Fired incineration, it requires a moisture content which should be less than 10 to 15%. Considered to be a well accepted moisture content of 15%, which considered to be ideal for effective thermochemical gasification of different biomasses. Now, when we talk about gasification, this is a well um, established technology for the thermochemical conversion of the biomass, and for this process there are different kind of gasifiers are used, which are determined what kind of gasifier we should use for specific biomass sources. These are determined by the amount of moisture content of the biomass. So you can see that how much crucial is to determine or to reduce the moisture content of the biomass, because um, that will decide the types of equipments or type of reactor in the downstream processes. Now, the gasifier, these biomass gasifiers are downdraft fixed bed type gasifier, because they are mostly applicable for small sizes and produces low quantity of the tar, undesirable product. Now, the moisture content which is above 20% is not applicable for this downdraft fixed bed gasifier. When it we have biomass of higher moisture content, 50 to 65%, that can be applicable for updraft fixed bed gasifier or fluidized bed gasifier respectively. So in this slide we have discussed that how that moisture content is affecting the selection of the different kind of equipments, or the specifically we have discussed about the type of gasifiers, that how it is related to the moisture content of the feed or the biomass sources. So now we will discuss in detail about the mechanical dewatering process that we discussed in the first or second slide. The mechanical dewatering method, it involves some equipments like screw pressing, belt pressing, or vacuum filtering, which are frequently used for the mechanical dewatering. Coming to the belt pressing method, belt pressed are mostly used in the swage sludge dewatering. When the swage sludge, it is also a great considered to be a great source of the biomass, which can be used for the different fuel production out of the those biomass sources. Now, this belt pressing, I'm giving you the schematic that you can follow. It consists of different rollers. You can see there are different rollers in the arrangement. The materials pass through one of the rollers. With the use of the rollers, the position tension of the moving belt are maintained. Now the pneumatic jacks are also used to adjust the belt tension, where the belt speed is regulated by the electric motor. Belt receives the power through the rubber covered roller, and the flocculates material was removed from the inlet of the belt press. Now you can see in the schematic that this is the sludge feeding this brown color, and it is coming slowly over the belt. And when it is coming over the belt and it is going over the uh, rubber covered roller, then this was is the pre dewatering zone, and in the process there are dewatering is happening. This blue color, you are you are seeing that the water is being collected from the uh, sludge over the process, and in between there are some external water source supply for belt washing system as a belt washing system. And in this region you can see the roller arrangement, so it is creating the press. These are considered to be the pressing roller. So between these two rollers, the belt on the belt the material is being pressed, and the other the maximum water removal is happening in this region. At the last we are having the this all the water is considered to be the filtrate. It is discharged, and the brown color uh, that symbolized here the sludge feed, it is now dried up and it is taken out as a product. So thus this is the dewatered product we are getting out of the um, belt pressing system. Next one is the screw pressing. In the screw press, to form the large flocks, the feed slurry is premixed with some appropriate flocculant, or you can say coagulant. The flocculated slurry is subsequently introduced into the open end of the press. So this is the flocculation tank. We are adding the flocculant here, suitable flocculant or coagulant here in the tank. It is well mixed, and then it is fed to the, this is the screw press, and this conical shape, the smaller dia end here, this is introduced in the system. The screen is narrower. In the open end there the flocculated slurry is introduced, and it features the largest hole, so here the feed is introduced from this direction, and the subsequent region is a low pressure filtration area where the remaining free water continues to drain. So here when it rotates some screw press system, we all know that it is rotate and it is pressing, and the filtrate is taking out as a water, extra water is being taken out, and in the process it will move on like this way over the screw, and it is the dried product is taken out as a dewatered sludge. The final section is the squeezing area, where both the free water and interstitial water, inherent water, is drained out. At the discharged end, a conical pressure mechanism restricts the removal of the filter cake by exerting a back pressure that enhances the filtration process of the cake. So this system is from this figure you can see that how the screw press is working, uh, defines the shape that it is conical, and feed is being fed from here in the open end, and it is rotating in such a way that when it comes to the end there, it is completely dewatered sludge we are getting as a outlet product. Okay. So next one is the rotary pressing. Rotary pressing also considered to be the mechanical dewatering process. A rotary press is dewatering machine that operates introducing sludge into the sequence of circular channels. So there are some rotary shaft is there. So in the circular motion, it is getting dewatered. Within this channel, the sludge is placed between two perforated screens that rotates at a low speed, 0.3 to 4 rpm. The back pressure is controlled by adjustable wedges and the filtrate passes through the screen, in which the flocculated sludge remains in the channel and forms cake near the outlet of the press. So here the biomass sludge that contains lot of water is being introduced in the rotary pressing system. Then it rotates, and when it comes to this end, all the dewater, because there are two perforated screens are there. So in the perforated, from the perforated screen, the water or the water content of the biomass sludge is being drained from the feed, and outlet product is the biomass cake which is dewatered. Next one, we are going to discuss about the thermal dewatering processes. So in the name, by the name you can think of that in the thermal dewatering process we are utilizing the heat to remove the water from the biomass. This technique works especially well with the biomass that contain lot of moisture, including the sludge and the waste material which are wet in condition. Through these procedures, including evaporation, thermal drying, flash drying, thermal dewatering may be accomplished. Heat is being applied to the biomass during the evaporation, which causes the water to vaporize. This procedure may be energy intensive, and it calls for precise temperature control so that our biomass sources are not damaged. Only the water is being removed from the feed, not the we should avoid any thermal damage of the biomass sources. Thermal drying is the process for removing the moisture from the biomass using the hot air supply or other heated gas, which should not be reactive in nature with the biomass, so we should consider that one. Dewatered material is produced when the moisture present in the biomass evaporates and it is removed by the drying medium. Here the drying medium is the hot air. By quickly exposing the biomass to the hot gases, the moisture is instantly evaporated. This process is known as flash drying. Fine and powdered biomass is well suited for the technique because there it has the high surface area, so the drying will be faster because it is a instant process. Coming to the chemical dewatering process, utilizing different chemicals to improve the water separation from the biomass is a key component for the chemical dewatering technique. Chemical dewatering techniques include flocculation, coagulation, settling, which are frequently used as a part of chemical dewatering. Chemicals which are added during flocculation and coagulation in order to encourage the aggregation of different suspended particles in the biomass sludge feed that aid their quick settling of those suspended particles undesirable. These substances somewhat refers to the flocculants or coagulants induces small particles to aggregate into bigger flocks that are very simpler to separate from the water. When the biomass is left to stand, solids may be attracted to the bottom by gravity. This settling method by these flocks are attracted at the bottom of the chamber by the gravity, and this process is known as settling. So the chemical additives can improve this particle agglomeration, and thus it will enhance the settling process. Next, we will discuss about the drying. Drying, which is a subsequent step after the dewatering, it has the aim to further reduce the moisture content of the biomass. In the convective drying situation, the moisture from the biomass is removed by the hot air or gas, any kind of hot gases. It is being circulated around the biomass while it is spread out on the surface or transported through the drying chamber. It has the aim to evaporate only the moisture content of the biomass. It has nothing to do with the any damage of the biomass sources. Only the moisture removal is happening. In the case of the contact drying, direct contact is maintained between the biomass and the heated surface in the aim to remove the moisture. In order to facilitate the direct drying condition, effective heat transfer and the moisture evaporation, the biomass often put on the heated drum or the belt. For biomass with having high moisture content or thus they are susceptible to the breakdown at a higher temperature, contact drying is frequently utilized. Means those biomass sources which are very sensitive to the higher temperature, it has the tendency to damage at a higher temperature. So for those cases, contact drying are suggested. In the microwave drying condition, the heat is produced inside the biomass through the electromagnetic waves, which causes the moisture to evaporate very quickly. Drying is happening in the microwave drying system. These methods have benefits including faster drying and homogeneous heating. So you can see this is the another kind of the drying system, that is rotary drying system. Here it is mostly used for the biomass to be dried directly heated condition in a single pass rotary dryer. Here the rotating drum accommodates both the hot gases as well as biomass material together. Okay, now the spinning this rotary dryer, this drum is spinning and the hot gas provided, it improves the heat and mass transfer. Mass transfer means water is being evaporated. The indirectly heated rotary drum uses steam source or hot air which flows through the outer wall of the dryer or through the central shaft of the dryer, and thus it is happening, the uh, heat is being transformed transport in the form of conduction. So here the blower, in the heated condition, the hot air is passes through the outer wall or through the center shaft. So that's why it is rotating and it is helping to dry out the moisture content of the biomass. Next one is another kind, which is the flash drying process. It is also known as pneumatic. It is also known as pneumatic drying system. The material is introduced into the high speed steam of hot air, which helps in the form of this hot air in the help of by the help of screw conveyor. So the small particles transverse through the long metal tube and the dried product is extracted from the air stream with the help of the cyclones and bag filter. Collected from this cyclone type of chamber. Now the high drying temperature here causes the flashing of the water vapor. That's why it is called flash drying. High temperature for the drying it is used, it causes the flash of the vapor, which cools down the drying gas without causing damage to the product. Now we have discussed a lot about dewatering and drying system and the involved equipment for dewatering and drying. Next one, we are moving forward with the discussion of size reduction as a physical pretreatment process. In the size reduction, we are going to discuss about the hammer mill, knife mill, discs and drum chippers, which are commonly used for the biomass size reduction. So, this is the schematic of the hammer mill. Here, the particle size reduction occurs as the feed material is stuck by the metal hammers. These are the hammers mounted on the spinning shaft or the drum. It is continuously hammering those bigger particles until it reduces its size to smaller, and then it is passed through the great aperture. Hammer mill, those are commonly used in the MSW or municipal solid waste processing system to reduce the size of the component before the RDF separation takes place. Refused RDF is nothing but refused derived fuel. Additionally, when the hammer mills are employed mostly in the forestry and the agriculture are cheaper. While they usually have lower capacity compared to the hammer mills, rotating cutters equipped with the knife blades, those are used for the application to reduce the particle size through cutting and shearing action. So here the hammer mill, it produces homogeneous product. So this is the hopper and feed is being introduced. The larger size feed material or particles are getting crushed by the continuous hammering process, and when its size reduction is happening at a extent that is maximum possible by the hammer mill, then the smaller size particles will pass through the opening at the bottom and it will be collected from the bottom of the hammer mill. Next one is the knife mill. In the knife mills, the rotating shafts are fitted with sharp edged knives alongside some stationary shear bars. Lignocellulosic biomass, it undergoes grinding in the knife mill through the continuous cutting action of the knives and also the shear presence of the shear bars. The resulting product, which is discarded from the knife mill through the aperture opening situated at the bottom of the container, similar to the uh, hammer mill uh, hammer mill design. The knife mill are preferred due to their favorable characteristics, including they consume low power, enhance the particle flowability, also and it narrow the particle size distribution. It also supports moisture content of the biomass feed up to 15%. This knife mill process involves the stationary use of the stationary and rotating knives to grind the biomass. Means in the compared to the hammer mill, the knife mill produces very finer biomass size reduction. There are many factors that will influence the milling action, such as number of knives, milling speed, particle size requirement, gap between the knives, and the angle at which the knives are being placed. So here it is the knife mill. In the on the shaft, rotating shaft, there are some placed knives are being placed, and in the similar kind of design of hammer mill, but here the grinding is happening at a greater extent and we are getting a powder product. Next one is the disc or drum chipper. So disc chipper are widely used for the pulp production industry. For rotation of heavy discs, the straight knives are attached and it runs at a speed about 400 to 1000 rpm. In this, the straight knives are attached to the rotating heavy discs. Drum chipper wire. We discussed about the disc chipper. Drum chipper consists of the steel cylinder with 12 or more knives arranged in the tangential alignment. The processing knives must be replaced every after 50 to 100 turns operation, and um every after 200 to 300 tons. The main chipper unit consists of the feeding unit, chipping unit, output unit. Those are very common system. Now the drum chipper produces more similar chips than the disc chipper. So the variation in the output is very less in the as a output of the drum chipper than the disc chipper. So this one is the schematic of the disc chipper. Now you can see um, these are some straight knives are attached to the rotating shaft here, and this will reduce the size of the input biomass. This is the some kind of wood log is being introduced into the disc chipper, and it is getting crushed by the disc chipper. So these are the processes of size reduction equipments, and those are widely used. Now coming to the next part, that is the densification process. The uses of the biomass directly for cooking or heating purpose is responsible for the air pollution, and it produces very bad impact on the living organism and environment, right? Now to avoid this problem, agricultural waste or residue can be converted into some solid biomass fuel by using the technology of briquetting or pellets. This is what named as densification process. So the densification or the briquetting technology, it plays a key role to minimize the problem of the high storage capacity and easy transportation. Briquettes or pellets is the best solution for utilizing the raw agricultural waste as a form of solid biomass fuel. Now, how this preparation of the densified biomass fuel is being done? You can see this flowchart. Raw biomass material, first it is received or collected, then it is grinded or crushed by those equipments that I have discussed in the last few slides. Then it is going for the drying or dewatering or this kind of thing. Dewatering and drying is happening at a previous step of this grinding, and then again it is dried, mixed with the binders, different binders, properly mixed, and then it is formed biomass pellets or briquette using the machines. And then when it is formed the solid fuel, then it is cooled and it is called as a biomass solid fuel. The various processes to prepare the biomass residue for compaction, those are drying, decreased size reduction, and mixing of different biomass residue in a suitable ratio, and mixing of the binder in a suitable ratio for this preparing of these pellets. There are various types of binders which are used to improve the quality of the briquettes. Those are biosolids or cassava or corn, gelatin, microalgae, molasses. It is highly used because it is easily available from the pulp industry. So sugar industry, sorry, sugar industry. It is highly yeah, easily available. It can be utilized here for the densification of the biomass, and a starch is also used as a binder. This binder is used for increasing the compressive strength and the mechanical durability of the biomass briquettes. So in the densification technology, three different compacting pressures are considered for briquette compaction process. The higher compaction pressure around 150 kilopascal is better for to improve the quality of the briquettes by using the cassava as a binder. This is an example only, that using this cassava binder and compaction pressure of 150 kilopascal, we can get a good quality of the briquettes out of the biomass sources. So what are the densification equipments used for the densification? First one is the screw compaction or extruder machine. Screw extruder has a rotating screw which exerts a force on the biomass residue coming on the feedstock for compression. There, the significant amount of energy is required to reduce the particle friction because the biomass residues are moderately compressed and cramped here. At a high temperature of 2000 to 2500 degrees Celsius and initial this initial temperature, the particles of the biomass, it gets their it improves their elasticity property and it becomes softer. And as it becomes softer and it causes the interlinking of the particle and it forms some local bonding. A particle having size range of 2 mm to 4 mm, these are ideal for the extrusion period because they are responsible for optimum binding of the biomass residues material. This high temperature of 2000 to 2500 degrees Celsius and this heavy compression, it makes the biomass material more appropriate for burning and co-firing processes. So this one is the extruder machine. So a similar kind of screws are being arranged here. So hopper from hopper the biomass is fed, and over here there are some heaters. Throughout the process it is being heated at a high temperature. Of this temperature is maintained, and here at the initial when it is introduced into the screw compaction machine, the first it is transports to the high melting zone. Here the melting is happening and then it is coming to the more the interlinking of the particle or the local bonds are formed, and these kind of pellets are being collected from the outlet of the screw compaction machine. Next one is the piston press machine for the densification. It is used the different pistons which is driven by the flywheel and or some hydraulic mechanism for the production of the densified biomass fuel. A biomass residue material which is coming from the feedstock unit into the cylindrical shaped piston drive is it can be driven by mechanically or hydraulically. For heating the biomass residue material, temperature maintained here 15,000 to 30,000 during the compression method. So it is high temperature operation.
Madam,
Yes.
see, once you check that temperature range, please, because I am having some doubt on it. Because
For
15,000, 30,000 what 15,000 degrees centigrade and to 30,000 degrees centigrade, what it is? And the
uh,
previous slides also you have shown that it is some 2000 to 2500 degrees centigrade. See, we are dealing with the biomass, and even if I don't think this much of temperature, we will not dealt with even metals. To be frank, I am having some doubt on it, and your that subsequent slide is 15,000 and 30,000. Not at all agreeable with it. Anyway, uh,
yeah,
doubt from my side.
I will check if this I have taken this information from a journal, so I will check with that again about the temperature. Okay, so in when I will upload the slide, maybe the the updated if it is needs to be corrected, then I will upload the updated temperature range in my slide. Okay. Thank you for mentioning it. I will check with that. This is the picture for the piston press arrangement. So here the biomass residue or the feedstock is being fed into the hydraulically driven pistons. So these are the pistons, and the biomass solid fuel are liquid here. So we are getting out as a product from this end. So it is being the biomass is introduced, and it is being hydraulically driven piston is introduced, and it is getting compact over the process, and we are getting the briquettes out of that. In the also it is maintaining the temperature. This is this temperature, I need to cross check this temperature again. So this temperature, in the high temperature zone, it is being compressed, and we are getting as a solid fuel or the briquette out of the piston press machine. So now next one is the roller pressure, where the two rollers are rotate in the opposite direction of each other. So the biomass residue material is fed through the hopper, and the flow of the biomass residue is material is controlled by the control mechanism. Now the forces now exerted on the predetermined quantity of the pre-compressed biomass residue material by the two roller, which continuously rotate in the opposite direction, and it can be dragged from one side, and densified product is extruded from the other side. The gap between the two roller, which rotates in the opposite direction of each other, it relies on the type of biomass residue which is used. Also, it is dependent on the content of the moisture, size of the particle, and the ratio of binders and other several factors. So this is the two roller arrangement, and it rotates in the anti-clockwise, though it is not properly maintained. So it is rotate, if it is rotating in the this direction, so it will rotate in the other direction. So it is rotating, two rollers are rotating in the opposite direction of each other. Now the biomass residue material is fed from this end, so it is by this compaction method, so we are getting the dried and compacted product out of the roller press mechanism machines. And some of the fine particle which are being produced and not of our desired product, that can be circulated back to the feedstock. Next one, we are going to discuss about the separation, which is the last part of the physical process considered to be. Then, using the separation techniques, the biomass can be converted into high quality products by removing the contaminants and extracting the valuable components. So, and also the valuable, okay. So this separation of the biomass is carried out several steps. Those are filtration, centrifugation, sedimentation, flocuation, and gravity settling. In the filtration method, the valuable solid is being separated from the fluid by providing a medium and permeable membrane through which the fluid can flow, but the solids are holded on onto the membrane. Now those collected solid particles on the membranes, those form a filter cake layer, and these are commonly used. The commonly used fillers is continuous rotating filter are used for this filtration process. An appropriate filter must be of low cost and must restrict the chemical attack. We should also keep in mind that it should resist the chemical attacks. So the commonly used equipment for this filtration process is the rotary vacuum filter. Next one is the process, the centrifugation, where the separation of the solid particle is happening. The solid particles are size ranging from 100 to zero point 0.1 micrometer. is being achieved from liquid by the gravitational force. Now the major principle here, the centrifugation is happening by the density differences of the particle. Centrifugal force is applied, and because of the density differences, the final product and the large coarser product are being separated. There are several types of centrifugation methods. Some of the examples are tubular bowl centrifuge or multi-chamber centrifuge, disc bowl centrifuge. These are some mainly used equipment in the process of centrifugation. In the sedimentation process, the solid particles have above 100 micrometer flow size are being separated, and this is very deliberate process, and this method is mainly used in the active sludge effluent treatment operation. In the flocculation, we have discussed few slides back that we are using different kinds of flocculants or coagulants to form those flocks, and smaller particles will be in a steady motion due to the electrostatic charge which brings the repulsion. So when the electrostatic force becomes neutral, these smaller particles will collapse and they forms the flock, and those will settle down. In the extraction process, which is very important, the biomass is extracted by using the different ways like acid base extraction, partitioning, or liquid liquid extraction. Liquid extraction in the help with assistant of ultrasound extraction, microwave extraction, or enzyme assistant extraction methods. There are lot of varieties, and the most popular technique is liquid liquid and liquid solid extraction for the biomass separation process. So we have discussed as a first part of this session, that is physical processes. Now we were moving towards the discussion of thermochemical biomass conversion processes. So here we know that biomass bioenergy can be converted from the biomass via two main types of processes. One is thermochemical process, another one is the biochemical or biological processes. Generally, thermochemical processes have higher efficiency than the biological or biochemical processes in terms of the lower reaction time, because few seconds or few minutes are utilized in the thermochemical processes, whereas in the biological processes they take several days or weeks, even it takes longer than that. And also the quality of the product out of the conversion is superior in the thermochemical processes than the biological processes. For example, when we consider the lignin, these lignin material are typically considered to be non-fermentable, right? We discussed in the last class that how it is like recalcitrant in property in nature, so it is not typically considered to be fermentable. Thus, it cannot be completely decomposed via biological means, whereas they can easily be decomposed by thermochemical approaches. Now, the thermochemical conversion processes mainly include direct combustion, pyrolysis, gasification, and direct liquefaction or hydrothermal liquefaction processes. So in this diagram, you can see that these are the four main thermochemical processes, and from here, from the pyrolysis, we get the solid product as well as liquid and gaseous product. Whereas in the liquefaction process, we mainly get the liquid or the oil kind of production, fuel production at a higher yield. From the gasification, we get mostly flue gases, and combustion we get as a out product as a heat source. So here the stored energy within the biomass that could be released directly as heat, or it can be heat via combustion or co-firing process, or this stored energy within the biomass can be transformed into the different solid products like charcoal liquid products like bio oils, and gaseous product like synthesis gas or syngas by the process of pyrolysis, liquefaction, or gasification with various utilization purposes. So, coming to the first part, that is the thermochemical conversion process, that is the combustion. It is most widely used process for the biomass conversion, and it contributes over 97% of the bioenergy production in the world. There are three main stages that occur during the biomass combustion. First one is drying, pyrolysis and reduction of the biomass sources, and then combustion of the volatile gas. Those are generated in this step, pyrolysis step, and then it produces the solid char. The combustion of the volatile gas contributes to more than 70% of the overall heat generation. So it takes place above the fuel bed and is generally evident by the presence of the yellow flame. When the combustion of the volatile gas occurring, you can get get to know about it by the by seeing the color of the flame, that is yellow in nature. Char is combusted in the fuel bed itself, and it is noted by the presence of some blue flames. The combustion of biomass on a large scale is still considered to be a complex process with various technical challenges associated with the biomass fuel characteristics, the type of the combustor you are using, and various challenges when it is co-firing with the existing conventional sources like coal or natural gas. In comparison to the fossil fuels, the biomass fuels have relatively lower heating value because they have high moisture content and high oxygen content. Due to these two factors, they have the lower heating value. Although the combustion reaction is exothermic in nature, the evaporation of the water becomes endothermic. So, to maintain a self supporting combustion process, the moisture content of the biomass fuels cannot be or should not be higher than 65%, because overall the reaction should be exothermic in nature. So we need to decrease the water content of the biomass fuel that are being fed into the combustor. Typically the oxygen content of the biomass is as high as 35 weight percent approximately, which is 10 times higher than the high rank coal, which has the oxygen content below 4 weight percent. Other challenges include fouling and corrosion of the combustor of the biomass. This this fouling and corrosion they consider to be detrimental because they result in the reduction of the heat transfer mechanism in the combustor. This fouling is commonly associated because there are some alkali metals and other elements like silicon, sulfur, chlorine, calcium, and iron. Those are present in the biomass ash. In the first slide itself, we have discussed that how the ash and moisture content affecting the conversion or the thermochemical conversion processes. So we have discussed lot about water content or moisture content, how it is affecting and how we can do the pre-treatment of that. So here we have discussed about the biomass ash, role of the biomass ash, because they are getting generated because of the presence of different alkali metals and these kind of elements which are present in the biomass, and they negatively affect the chemical reactions, because there are a series of chemical reactions and they form the deposit in the form of chloride, silicates and sulfates on the wall of the combustor, and they reduce the heat transfer. So we use fixed bed, fluidized bed, entrained flow reactors. These are typically three mainly used combustion system. With increasing the carrier gas velocity within the reactor, we uh, optimize the thermochemical processes. A higher gas velocity, it translates to an intensive mixing of the feedstock, which enhances the combustion efficiency and with enhances the heat exchange rate also. Hence, the entrant flow system out of these three would be expected to exhibit the uh, best performance as a combustion system. Now, the fixed bed system they have widely used for the biomass combustion for years, and a fixed bed biomass combustion system is typically operated around 850 to 1400 degrees Celsius. Generally, as soon as the new biomass feed is added into the fixed bed furnace, it is getting pyrolyzed, and it forms the volatile gases, and it forms also the solid chars. The primary and secondary air circulation under and above the grate for the combustion of the char and those volatile gases are being maintained by the primary and secondary air circulation. Because of the high content of the volatile matter of different biomass fuels, a greater secondary air supply is always required than the primary air supply. Now, comparative to the fixed bed system, the fluidized bed system have higher combustion efficiency, and they are reported to be more suitable for the large scale operation. Fluidized bed systems they employ the silica sand, limestone, dolomite, and other non-combustible material as a bed material of the fluidized bed. The typical operating condition temperature is 700 to 1000 degree for the fluidized bed, which is comparatively lower than the fixed bed system. In the fluidized bed combustor, the biomass is intermixed with the moving medium, and it gives the high combustion efficiency. So depending on the blowing air velocity, fluidized bed systems can be further divided into, it can be bubbling fluidized bed system or circulating fluidized bed system. In the entrant flow reactor, the third kind, the fuel particles are transported into an externally heated silicon carbide tube, which is pneumatically controlled through an insulated and water cooled injector. Now, prior to the injection, the feeding stream composed of air and fuel particles. They pass through an agitation chamber for disaggregation or filtering of the pulses in the feeding. Now, the feeding fuel is ignited by the presence of natural gas or air in the burner at the reactor entrance. So, this different kind of the equipment design and how it is being operated for the combustion, those will be discussed in maybe in later some of the classes, but not today. We are mainly focusing on the processes, the fundamentals and process operating conditions in today's session. So now coming to the one important factor, that is co-firing as a part of combustion. Co-firing biomass and coal directly by burning biomass and coal, or indirectly gasifying the biomass at first hand, and then to produce some clean fuel, and then it is burnt in the presence of the coal. There are two options. Now, these co-firing biomass and coal, these are proven to be cost-effective technology to achieve the goal of increasing use of the biomass to energy processes for the power generation. So, in comparison with other thermochemical processes, biomass utilization and bioenergy production, co-firing becomes a promising and cost-effective method, because with the few modification only, they can be upgraded. They can be utilized in the or existing coal-based power plants. Various types of biomass, such as woody biomass or herbaceous material, agricultural residues, and energy crops, can be easily co-fired with different types of coal. They are in the percentage fraction as high as 15%. Biomass co-firing with the coal that could reduce the occurrence of this fouling that I discussed in a few slides back, and the corrosion problem. when compared to the case where only the biomass is being used. Due to the dilution and consumption of different alkali metals via interaction with the sulfur or in sulfur or silica present in the coal, so here the dilution occurs, so the fouling and the corrosion problem reduced. In addition to the coal, biomass can also be co-fired with the natural gas. So here the co-firing of the natural gas with the clean fuel gas that is being derived from the low heating value of biomass material, that can be another promising option for the bioenergy utilization. So when the biomass is simply blended with the coal and then it is introduced, then the blended mixture is being introduced to the boiler. So in this case, due to the inferior property of the biomass, that is the property that we are going to mention, the high moisture content and low bulk density of the biomass, this simple blending and this kind of feed mixture, the co-firing processes are normally limited to low co-firing ratios. But the other way, when the biomass feedstock is being processed separately and injected into the boiler through some dedicated lines, although this is the other option that we are not blending it beforehand, we are feeding the biomass feedstock in a different dedicated line into the reactor. So, although the biomass introduced is separated from the coal, this separately they are introduced. The feedstock are combusted in the combustor in simultaneously. So, a common challenge for above these two discussed categories is the fly ash composition, which is caused by the addition of the biomass. So, there are compositional change in the fly ash. So this is the variation is happening because of the different biomass composition. Next process of the thermochemical process, those are pyrolyze. This is very important process. It is considered to be also industrially applicable, industrial scale it is applicable. So this is the thermal decomposition process takes place in the absence of oxygen to convert the biomass into solid charcoal, liquid bio oil and gases at elevated temperature. So based on the thermal gravity analysis that we do as a testing method, you can say, there are we have marked three stages for typical pyrolysis process. The first step is considered to be drying, which is occurring below 150 degrees Celsius. So here what happens, the free and bound moisture evaporates with significant thermal degradation. Without thermal degradation, only the free and bound moisture evaporates. So there is no significant chemical reaction that occur below this 150 degrees Celsius. Only the physical water loss is happening. So the TGA curve that I will show in the next slide, they show slight decline in the mass. The second stage is active pyrolysis. It covers 200 to 500 degrees Celsius and they primarily consist thermal decomposition stage where hemicellulose, cellulose and lignin undergo degradation in different temperature region. That TGA curve that show the steep mass loss, they indicate the significant release of the volatile gases. So from the TGA DTG curve, the DTG curve typically exhibits two or more peaks. So when we get the peak of nearly 200 to 300 degrees Celsius, it denotes the hemicellulose degradation. 300 to 400 it comes like cellulose degradation, and after that it have the broader degradation range for the lignin. The major pyrolysis product in this active pyrolysis are bio oil and some gases, carbon monoxide, carbon dioxide, methane and hydrogen gases, as well as biochar. And the last stage, that is the residue only, that happens around 800 to 900 degrees Celsius, where very less change in the mass loss is observed. It indicates the final residue left, mainly the ash and unconverted carbon. The final mass represents the inorganic content of the biomass sources, which is mineral, metal, and other non-volatile compounds. So this is the TGA DTG curve for for lignocellulosic biomass. So you can see this dotted line is the DTG curve, uh, which denotes the percentage decomposition per minute. It refers to the rate of decomposition. So here you can see 200 to 300, there is a peak, it represents the hemicellulose. For black one, it is 300 to 400, it represents the um, uh, it represents the lignin, and lignin still gets decomposed over the white range after that. And the cellulose, it is happening at the 300 to 400 in this region. So this is the DTG curve, and TGA curve, this almost the same. It um, up to 150 degrees Celsius, it almost constant, and then it is getting sharp decrease. So it represents the water loss of the biomass feedstock. Then it is coming down, and it represents the steep one, it represents the lot of um, decomposition happening, that is the active pyrolysis zone. And later one, it is the residue zone, or the um, final decomposition zone, you can say. So there are when we talked about the active pyrolysis, which is in the range of suppose 300 to 500 degrees Celsius. So there are some types of the pyrolysis depending on the reaction temperature and the residence time. So this is divided: fast pyrolysis, intermediate pyrolysis, and slow pyrolysis. So in this we can see that fast pyrolysis, these have moderate temperature around 500 degree, and they have the short vapor residence time around 1 second. So our product of the fast pyrolysis is mostly the liquid product, gaseous product. Most contribution is liquid product, and there are other product of char and solid and gas product. In the intermediate pyrolysis, the moderate temperature is maintained 500, less than 500, and the moderate vapor is also, vapor residence time is maintained around 20, 10 to 20 degrees Celsius, where also the liquid product or the bioil production is highest, and also there are other contributions of char and gaseous product. Whereas the slow pyrolysis, also known as carbonization process, low temperature is maintained around 400 degree, and very long residence time is maintained for the slow pyrolysis. For that we are getting high contribution of the char and gaseous product, and liquid product getting produced at a lower content. So several factors needs to be considered to maximize the liquid yield production in a fast pyrolysis process. This may include the finer particle size, which should be less than 1 mm, and a careful controlled temperature, for which it has been reported that the optimal temperature range should be in the range of 450 degrees Celsius to 550 degrees Celsius for the fast. The optimum temperature to obtain the highest bio oil yield, and a heating rate of greater than 200 degrees Celsius per second. Shorter residence time less than 4 seconds is typically maintained, and a rapid cooling of the vapor. So these are the process condition to get the higher yield of the bio oil out of the fast pyrolysis process. The most commonly used reactor for the fast pyrolysis are bubbling fluidized bed, circulating fluidized bed, and end-to-end flow reactor. In addition to the biooil production from the fast pyrolysis, it is also reported that we get lot of hydrogen gas at a higher temperature of 700 to 1000 degrees Celsius. Two types of reactions are involved, which is mainly responsible for converting the methane and hydrocarbon vapors C2 to C5 carbon content and simple aromatics into hydrogen. The first one is the steam reforming reaction, which converts all the hydrocarbon into carbon monoxide and hydrogen. You can see this is the hydrocarbon common structure, and with the presence of the steam, we are getting hydrogen and carbon monoxide. The next reaction followed by that, this carbon monoxide is react with the water or steam to form the hydrogen and carbon dioxide, which is known as water gas shift reaction. So this is the reaction. Carbon monoxide is getting reacted with the steam. We are getting hydrogen and carbon dioxide. The potential hydrogen yield is positively correlated with the high steam to carbon ratio in this process, and the presence of proper catalyst such as co-precipitated nickel aluminum catalyst or other catalysts like Syria zirconia supported on platinum or platinum catalyst in the system. So their catalysts are important. Now, the moderate and slow pyrolysis, in contrast to the fast pyrolysis process, slow pyrolysis doesn't require fine feedstock, particle size, and also a conventional pyrolysis process in a rotary kiln reactor or a moving bed reactor can be used for raw material. Those are not available as powdered or fine particle. The product charcoal can be utilized in a wider range area. Charcoal, which is the main um, product of the moderate of the slow pyrolysis mostly. So these can be used in a domestic cooking or heating purpose of the metallurgical or chemical use for raw materials for production of different chemicals, activated carbon, absorbent, and other pharmaceutical use. So next process is the gasification, which is also a important process as a thermochemical conversion. So here the biomass gasification is the process that converts the um, that the biomass into combustible gases like hydrogen, carbon monoxide, carbon dioxide, and methane with specific heating values in the presence of partial oxygen supply. Typically, 35% oxygen demand for the complete combustion is required. So here we supply partially oxygen, very low oxygen content is available for this combustion, for this gasification, or suitable oxidants are used also like steam gasification or in the presence of carbon dioxide. When the air or oxygen is employed, the gasification is very similar to the combustion, but it is considered as the partial combustion process. Now, the gasification is considered to be more environment friendly because the lower emission of the toxic gases is happening into the atmosphere, and the more versatile use of the solid byproducts where we can use the byproducts of the gasification process. Now, the gasification can be viewed very special form of pyrolysis taking place at a higher temperature to achieve the higher gas yield. So here the in the process of the gasification we are getting higher yield of the gases, synthetic gases. Biomass gasification offers several advantages such as it reduces the CO2 emission, it also compact the equipment requirements with relatively small footprint and accurate combustion control and high thermal efficiency. The product of the gasification, which is syngas mostly, it is a gaseous form of the bioenergy. Right, in terms of the specific heat values, synthetic gases can be classified into four groups that will be discussed in the next slide. Now the pyrolysis, it becomes the first stage of the biomass gasification. During this stage, the biomass feedstock are decomposed into tar and volatile hydrocarbon gases that contain certain quantities of the hydrogen before the commencement of the gasification reactions occur. Then, when these volatile hydrocarbon gases are evolved in the process of the pyrolysis in the first stage, thereafter there takes place a series of reaction in the gasifier. So these are the series of reaction involved in the gasification. The first step is the pyrolysis reaction, where we get the product like carbon dioxide, steam, this vapor, and methane, carbon monoxide, hydrogen, and other hydrocarbons. So these carbons are converted into carbon dioxide. Some carbon monoxide is also formed. So here the important reactions are this water gas reaction. Here the carbon is converted into carbon monoxide and carbon dioxide, and they form they follow the methanation reaction, when carbon monoxide is reacted with the hydrogen that is present within the, that is being formed within the reactions, series of reaction. So we are getting methane out of the product, and this methanation reaction, so as a product we are getting carbon monoxide, methane, and hydrogen. It is a combination of gases we are getting from the gasification process. So now we are going to discuss about the gasification versus combustion. What are the main differences, right? So, first, when we are talking about gasification, so it creates the valuable and environment friendly some products from the waste or very lower value, lower energy value material. Where the combustion, it is greatly generate only heat, or by the means of destruction of the waste, right? So the process type in the gasification, it follows the thermal as well as chemical conversion with no or limited oxygen present. In the combustion, we get the complete combustion with excessive presence of the oxygen. While in the gasification, the raw gas composition before the gas cleanup is having particulates, hydrogen, carbon monoxide, ammonia, and H2S. These are some impurities. Whereas in the composition, in the combustion process, we are getting lot of shocks and knocks from in the outlet gas. So after the gas cleanup, that you can see the syngas cleanup is happening at atmospheric condition to high pressure condition depending on the gasifier design. Now this treated syngas can be used for chemical various chemical generation, as well as it can be used for the other fuel production or power production. So recover sulfur species in the fuel, as well as in the form of sulfuric acid. So we are utilizing all of the impurities in the gasification product of the gasification product. Whereas combustion, the flue gas cleanup is happening at atmospheric pressure, and the treated flue gas is discharged to the atmosphere. We are not utilizing it. So there are some drawback of the combustion process. It is mainly used for the heat generation or the power generation. So main solid product of the gasification is char or slag, whereas the combustion, it is getting solid byproduct is char or slag, and for the combustion it is fly ashes and some other slag or bottoms. Coming to the ash or char or slag handling matters. So gasification, it operates comparatively low temperature processes, and it produces char that can be used also as a solid fuel. High temperature processes, when it produces the slag, these are non-leachable, non-hazardous, and becomes more suitable for non-hazardous materials, suitable for use of the construction material also. Uh, and the fine particulates which are generating by the gasification process, this also can be separated and recycled to the gasifier again. But in the combustion process, the bottom ash and the fly ash are collected, treated, and disposed as a hazardous waste in the most of the cases, or can be sold as a material for the concrete making. But this utilization is limited in compared to the gasification process. And mostly other thing is pressure. Gasification is happening as atmospheric high pressure, but combustion is happening at a atmosphere. This is nothing but overview of the difference between gasification and combustion. These sounds to be very similar, but the main difference is the presence of oxygen. In combustion we are getting for excessive presence of oxygen, while in the gasification we are having limited or no oxygen condition. So, and other difference is the product utilization. So this is the various kind of gas, synthetic gases that we are getting as a gasification product. One is the low heating value gas, that is typically having heating value of 3.5 to 10 megajoule. It is used in the gas turbine fuel, boiler fuel, and for smelting fuel. Medium heating value gas, that is produced as a product of gasification, 10 to 20 megajoule per meter cube. It is also used hugely for the hydrogen production, fuel cell feed, chemical and fuel synthesis. Also, it is and substitute the natural gas with the methanation process. High heating value gases having heating value of 20 to 35 megajoule per meter cube. This has the gas turbine fuel and synthetic natural gas production. They can be used because they are having high heating value, and also they are suitable for the various chemical and fuel synthesis. Substituting a substitute natural gas which is having heating value more than 35 megajoule per meter cube. These are the mainly application is it is a great substitute for the natural gas. Hydrogen and chemical production is highly applicable for this kind of sources of synthetic gas with high um, heating value, and also this can be a good source for the fuel cell feed. The next and the last discussion of this session is the hydrothermal liquefaction or direct liquefaction process. So it is a very low temperature and high pressure condition process during which the biomass is broken down into fragments, small molecules in the water or another suitable solvent. Or water can be used mostly because it is considered to be a green solvent and green process can be maintained. So these smaller fragments which are unsuitable and reactive, they can be repolymerized into oily compounds with various ranges of molecular weights. Direct liquefaction has have similarity with the pyrolysis in terms of the target product, that is the liquid product. Pyrolysis means fast pyrolysis. However, there are difference in the terms of the operational condition, right? Like direct liquefaction requires low reaction temperature but high pressure. Um, High pressure because pyrolysis is happening at a low pressure zero point 0.1 to zero point 0.5 megapascal, whereas direct liquefaction is happening at a high pressure of 5 to 20 megapascal. Superior to pyrolysis, this hydrothermal liquefaction, they produce better quality of the bio oil, which contains various chemicals including vanillin, phenols, aldehydes, and various organic acids. So, in addition to that, drying of the feedstock is not necessary step for the direct liquefaction, and we can use lot of aquatic biomass conversion in this process. But you can see that in contrast for pyrolysis process, the drying of the feedstock was necessary step. So lignocellulosic biomass material are most widely used for biooil production through this direct liquefaction process. Now lignocellulosic materials, those are rich in hydroxyl groups, so they can easily be converted into intermediates by the direct liquefaction process for the production of different biopolymers such as epoxy resin, polyurethane foams, adhesives for plywoods, etc. So at the beginning of the liquefaction process, the biomass undergo the depolymerization and then it is decomposed into monomer units. These monomer units, however, may be repolymerized and or condensed into solid charts, which are undesirable in the direct liquefaction process because we are having the aim of production of more bio oil out of the hydrothermal liquefaction. So, a solvent is generally added to slow down the higher ordered solid state reaction. thus reducing the detrimental condensation reaction. Generally, the biomass liquefaction yield is positively correlated with the dielectric constant of the solvent. Higher the dielectric constant, higher will be the bio-oil yield. Catalysts are always essential for the liquefaction as it can reduce the required reaction temperature. Also, it can enhance the reaction kinetics and improve the yield of the desired product, which is the bio oil in this case. Alkali and acids are two typical groups of the catalyst employed in the biomass liquefaction process. So, So this is all for today's class. We have discussed about the thermochemical conversion processes. In the next class, we will discuss about the other microalgae conversion processes, algal conversion processes. So, is there any question as of now? Okay, so in the next session, we will discuss about the other conversion processes. So we will meet in the next class. If there is no question, then I would like to end this session here. Okay, thank you for joining. We will meet in the next session.